Okay, so hello and good day everyone. I am Jomarie from CPE2A and I am presenting to you this time my operating system final PIT, which is with regards to the dining philosopher's problem. So I have run it using the C because my Ubuntu is currently on bug in this laptop that I have. However, this code is still in C and then with the syntax using of C. So let us proceed to the program description. So for the procedures, we have here the main, think, eat, and philosophers. So the main, it creates 5 threads for 5 philosophers and initializes 5 semaphores for 5 forks. While think, it lets a philosopher to think, and then eat lets a philosopher to eat. While the philosopher procedure will allow each philosopher to think and eat, allows philosophers to eat only when the forks on both of the philosophers left and right are available. While the philosopher is eating, those two forks are locked. So these are the required libraries. So this is the used. So the stdio.h, stdlib.h, pthread.h, semaphore.h, time.h, here now and .h and ctype.h. So let us proceed to the main code. So first, this part of the code, this is where the preprocessor macro to handle an error that has an error number. So I have defined this part of the code to store the error number and print the error message to the SDRR and terminate the program with the value of exit underscore failure. So let's proceed. So next, I have defined here num underscore threads 5. So this is the number of philosophers and also the number of threads in this code. So in this part of the code, this is the array of philosophers IDs, which is 0, 1, 2, 3, and 4, which is also equals to 5. And then next is the array of 5 semaphores for the 5 forks on the table. So let us discuss this part of the code. So void think int n. So void think int n is a function that lets a philosopher think and displays a message saying which philosopher is eating. And it sleeps for a random number of microseconds and after that displays a message saying that the philosopher has finished thinking. So this is where the structure to hold the time of the day, and this is the structure to get the time of the day. So this print is will allow us to display which philosopher is thinking, and then this part is the seed. This is to seed the random number generator, and then this is let the philosopher think for a random number of uh, microseconds between 0 to up, and then uh, within microseconds by letting by the function sleep for that number of seconds. So in this part, it will display a message saying that the philosopher has finished thinking, and that will be the end for the uh, void think in n. So let us proceed to void eat in n. So basically this function lets the philosopher to eat and then displays a message saying which philosopher is eating and the time at which the philosopher starts eating. Then it also sleeps for a random of number of microseconds, and after that displays a message saying that the philosopher has finished eating and the time at which the philosopher has finished eating. So let's discuss this part of the code. So this is a variable to hold the raw current time, and then this is the structure to hold the current local time of the PC. And then this is also a structure to hold the time of the day, and then this is to get the time of the day. So this is just also the same. This is to get the raw current time, and then next is to get the current local time. So this part of the code, as you can see here, is a printf. So it displays which philosopher is eating at the same time at which the philosopher starts eating. So basically, it will display who is eating and what time the philosopher is eating. Then this part, um, it see the random number generator, then lets the philosopher eat for a random of number microseconds. And then after that one, we will get the uh, raw current time, and then get the current local time of the PC, and then display the message saying that the philosopher has finished eating, and also the time at which the philosopher finishes eating. So that will be the end for the void in end. So let us proceed to the void philosopher. So this is the method where in uh, this is function that allows a philosopher to think and eat. So the function first allows the um I mean the function first allows the philosopher to think by calling function think. So it then uses semaphore to lock the fork on the philosopher's left and another semaphore to lock on the fork on the philosopher's right, and then allows the philosopher to eat by calling function eat. And then after the philosopher finishes eating, it unlocks the right fork semaphore followed by the left semaphore. So let us see how it is done in the code. So this is part of the code is to get the philosopher's number. And then this continuous loop in which the philosopher thinks and eat. So this part, uh, it calls for function think to let the philosopher think, and then uh, this part, it gets the fork, and then the right fork and then the left fork, and then mm, it allows the next part to call function eat. So it allows after calling function eat, it puts down the the put down the right fork and unlock the right fork, and then put down the left fork and then unlock the left fork, and then return null to exit from the function. Then end of void philosopher, which is this. So this is the int main. So mainly the int main, it initializes the semaphore for the 5 forks and then spawns 5 threads, one for each of the 5 philosophers, and then it then sleeps for 300 seconds or about 5 minutes to allow the threads to run for 300 seconds, and then kills the thread after 300 seconds. After that, it joins the thread and finally destroys the semaphore. So let's discuss the code. So this part is an array to hold the thread IDs of the philosopher threads, and then this is the initialize of variable I to counter for loops, and then S, variable to hold the value returned by function calls from the pthread library. Then next, num threads times to create 5 threads representing the 5 dining philosophers, and then this part is where it creates a thread for each 5 philosophers by calling phthread and store the function return value in S. So it's just the same for the next consecutive. And then this part, it sleeps for about 20 seconds to allow the threads to run for 20 seconds. Then next part is also a num thread to conceal and hence kill the 5 threads. So it also the same, it conceal and kill each thread by calling pthread underscore conceal, and then store the function's return value in S. Then it's also the same in here and the same in here. Then the program will now exit, or it will uh, display a message before exiting in the program. Then exit the program and then end of int main. So that's mainly the code for our dining philosopher problem solution. So let us now try to run and then understand how the output works. So if you try to run this one, this is how it would look, because it will repeat and repeat into infinite. So that is how the code. But however, I will display a code where you can understand more. So this is also a example of how the code runs. So as you can see, that on this part, uh, there are the philosophers are arranged on the random. So 4, 2, 3, 1, and 5. So as you can see that um, this part, 4, 2, and 5 is thinking, while philosopher 3 and 1 is eating at the time of 44 minutes and 49 seconds, which is also the same because we have set in the program in the time that they will um, took is for just microseconds, for because this is just a simulation. And then after that, the philosopher 1 has finished eating, um, 5, I mean, after philosopher 1, 5, and 1 and 3 is finished eating, 5, 2, and 4 is also finished thinking. And then at this part, philosopher 1 is eating, and then 5, 2, and 4 is eating, while the philosopher 1 and 3 is thinking. So that's basically how the code works. So at this point in time, it just repeat. So the philosopher 1 is eating, and then philosopher 3 is eating, while the 3 is thinking. So I think that would be all. And thank you.